Alright, transcended back here, guys. So let's go over ion electron method. So this is actually a method that we get to balance chemical equations in acidic and basic media. Okay. So I've got a couple of questions that are going to help us understand how we do it. So just before that, let me give you the steps that are very important. Step 1, you need to split the main equation into the half reactions. Okay. So after you split them into the half reactions, the second step is now to balance you need to balance the atoms in the half reactions. So you need to make sure that what you have as a reactant and as a product in the half reaction, the atoms are balanced. So the atoms that you're supposed to balance are supposed to be the other atoms other than what? Except oxygen and hydrogen. So in the third step now, this is where now you need to balance what? Oxygen. So you balance oxygen by adding water. Okay. So what that means is, if you have, for example, 2 oxygen atoms on the reactant side, then on the product there is nothing, you're supposed to add 2 water molecules, which will give you 2 oxygen atoms. Okay. So the moment you do that, you have to balance now the hydrogen atoms. So in that case, there are 4. So that gives us our fourth step. So the fourth step is by you balance what? You balance the hydrogen atoms. So the last step is now to balance the charge. Okay, so let's try to see these steps in the actual work. Okay, so step 1, we need to split into the half reaction. So we have Sn is kind of related to that part there. So get it. I'll write it the way it is. Sn is equal to so that is the half reaction that we have, the first one. The second half reaction that we have is NO3 minus is giving us nitrogen dioxide. Okay, so let's try to balance it now. So if you look at the first half reaction that we have, we need to balance the other atoms other than what? Other than oxygen and hydrogen. So we have this, which is already balanced. So we just have to balance oxygen now. So we are saying we balance oxygen atoms by adding water molecules. Okay. So we'll add 2 water molecules on the left. So this has helped us balance the oxygen atoms. But the moment we've done that, it has brought in hydrogen atoms, which are 4. So we are supposed to add them as well. Okay. So we've balanced now the oxygen atoms and the hydrogen atoms, and all the other atoms are balanced. Let's try to look at the second half reaction. So by inspection, we're able to see that only the oxygen atom is missing on the right hand side. So we'll add a water molecule by what? On the right hand side. Okay, so NO3, so we have 2 there plus that one, it makes it 3 already. So the moment we've done that, you are going to see that you've brought in the issue of the hydrogens. So we are supposed to add them on the left hand side. How many are they? There are 2. Okay, so 2 there. There are also 2 on the right. Nitrogen, it's 1. Oxygen, there are also 3. So we've balanced now. We've balanced. So we've balanced. So after balancing now, we need to balance the charges as well. We need to make sure the charges are balanced. So let's try to add the charges. I'll start with the first half reaction. So water doesn't have a charge, so it is 0 plus. This one doesn't have a charge. There's no charge there, so it's 0 as well. So on the reactant side, for the first half reaction, we have a 0 charge. Then on the products, we only have that charge there. So how many are there? There are 4. So we have positive 4. Okay. So we have positive 4. Okay. Then we go to the other half reaction. So here it's positive 2 because of that. There are 2. Okay. So positive 2 minus 1. So it's that negative where that's where it's coming from. So 2 minus 1, we are going to have a charge of what? Positive 1 on the left. Then on the right, we just we don't have a charge. We don't have a charge, so it's a 0 there. So we have a charge change from 1 to 0. So we need to identify which one is oxidation and which one is reduction. Okay. So this one is we are having a decrease in charge from 1 to 0. So meaning that there was gaining of an electron, because an electron represents a negative. So we'll say plus an electron. So that electron has made the charge to go to 0. So negative 1 plus this 1 that we have is going to give us what? A 0 that we have on the right hand side. So going back to the first one, we had the charge from 0 to 4. So that is oxidation, meaning that we had loss of what? We had loss of electrons. So how many were they? They are supposed to be 4. Okay, so let me show them there. So plus 4 electrons lost. So that gives us the charge now. Okay. So we've balanced the charges. So from this step now, we need to make sure that since one reaction here, one half reaction is losing electrons, the other one is supposed to gain. So the number of electrons gained and lost are supposed to be the same. In the first half reaction, we have 4 electrons being lost. So we need to make sure that even in the second one, there are supposed to be 4 electrons being gained. So you need to multiply the whole equation by 4 so that we balance. So we're going to have 4 electrons plus 8. So this by 4 plus 4. Then on the right, it will be 4 nitrogen dioxide plus 4 water molecules. Okay, so we've balanced now number of electrons. So let's try to cancel out the things that are common. So we can cancel out the electrons there. They can go away. Okay, we've cancelled the electrons. So we now need to add the reactants together from the first half reaction and the second half reaction. Okay. So most of the times we prefer to start with the oxidation half reaction. So I'll start with 2 water molecules from the first half reaction plus SN plus 8H plus 4NO3. So that is what we have. Then on the product side, we have 4 nitrogen dioxide plus 4 water molecules. Okay, so this is what we have. Now, do we have anything that is common on the reactants on the product side? Yes, we do. So we have got 2 water molecules there. Even here we have 4. So we subtract 2 from both sides. So we're going to remain with 2 water molecules. I'll use a different color. So 2 water molecules are remaining this side. Okay. So we remove that. Since we've cancelled out, we remove this as well. Okay. So we've balanced now. We've balanced. Okay. So actually the water molecule is supposed to be down here because it's part of this the products. So 2 water molecules. Okay. So if you try to look at the 2 equations, right? So on the product side, we need to show SnO2. So we've only shown this and that. So we're remaining with it. Let me move this to the left a bit so that we have enough space. So not forgetting there's a negative there. Okay. So on the products, what are we saying? So we are saying we have what I've written down there for nitrogen dioxide, but we also have this from the other half reaction, SnO2 plus 4H plus. So I'm supposed to write them in the same line, but because of lack of enough space, these others are down. Okay. So we still have the hydrogen atoms being common on both sides. So cancel. So the ones on the right hand side, since there are 4, they are going to disappear. Okay, they will disappear. Then out of the 8, we remove the 4. We're going to remain with 4. Okay. So this is basically now the complete balanced equation using ion electron method. And this actually summarizes what you're supposed to do in acidic solution. So how do we tell it's acidic solution? So it's acidic when you have the protons, the hydrogen atoms present. In a case of basic, as we will see in the practice examples that we have, we are supposed to add the hydroxide ions at this point. So we understand better. We have a second question there. You can feel free to pause the video, try out the question, then come and watch and see the solution. Okay, so as usual, we're supposed to split the equation into half reactions. So I have bromine, O3. So which one is it related to? So it's related to bromine. Okay. The second half reaction is hydrogen iodide. It's related to iodine 2. Okay. So let's try to balance now. Let's try to balance. So from the first half reaction there, what do we need to balance? We need to balance the oxygen atoms because bromine is 1 and 1. So how many oxygen atoms do we need? We need 3. So we'll add 3 water molecules on the product side. In the second one, before we even got the second one, guys, what else do we need to balance in the first one? So we need to balance the hydrogen atoms because we've introduced them as the moment we were introducing the water molecule. Okay. So how many are we going to add on the left hand side? So 3 by 2 will give us 6. So 6 hydrogen atoms. Like that. So we've added 6 plus bromine or 3 plus bromine there. So we've balanced the first one there. We can move on to the second one. So if you look at the second one, we only have one type of an atom, which is iodine. And here we have 1, there we have 2. So we need to introduce a 2 this side. And we've balanced. Okay? We've balanced. So from this stage now, we've balanced the atoms on both equations. So it's a matter of going out to the charge, first of all. We got the charge. So I'll start with the first half reaction. So we have that positive charge by 6. So we have positive 6. Then we have a negative charge, so minus 1. On the products, we have that charge, negative 1 only. So 6 minus 1 on the left, it will give us positive 5. Okay. So positive 5. So we have positive 5 there. So we have a change of charge from 5 to negative 1. So whenever there is a decrease in the charge, it tells you that there was gain of what? There was gain of electrons there. Okay, let me move this one a bit down. Okay. So let us even remove that. So we have a charge change from positive 5 up to what? Up to negative 1. So is that oxidation or reduction? It's reduction. So how many negatives are we supposed to put on the left to make it negative 1? So what number can you subtract from 5 to get negative 1? So 6. It's minus 6. So meaning that 6 electrons were gained. So show that. So plus 6 electrons. So 6 negatives plus 1 negative, it gives us negative 7, plus 6 positives, it will give us a negative 1 that we're having on the product side. In the second one, the charge here is 2 times the negative there. It is negative 2. The other side, there is no charge, so it's 0. So from negative 2 to 0 is an increase in a charge. So what are we supposed to add to negative 2 to have a 0? It's a 2. Okay. So these are the number of electrons that were what? That were lost. Because it's an oxidation reaction. Okay, so we need to balance now the number of electrons lost and gained. In the first one, we have 6 being gained. In the second one, we have 2 being lost. So we need to multiply this one by 3. So that if you multiply it by that, it will give us 6 electrons. So what do we have? So we have 6 iodide giving us 3 iodine plus 6 electrons. So we've balanced the number of electrons there. It's now the matter of combining these two equations to come up with the overall balanced chemical equation. So let's try to cancel out the electrons. Okay, do we have anything else common? We don't have. So the equation is going to be 6 hydrogen atoms plus bromine, or 3. So these have come from there. What else do we have? We have 6 iodide from the second half reaction. Then the products, what products do we have? So we have bromine negative plus 3 water molecules plus 3 iodine 2. So 1, 2, 3. So this is the overall balance equation in acidic media. It is shown by the presence of the hydrogen ions. Okay, in the third one there, so we have that. So H2O2 plus ion 2 giving us ion 3. These are actually supposed to be the charges. Okay. So it's ion 2 plus, ion 3 plus, plus water there. So let's come up with the half reactions in this case. So the first half reaction, if you look at this, it's more related to the water molecule. So write it. So are the atoms balanced? So hydrogen is balanced, but oxygen is not balanced. So where do we have a shortage? We have a shortage on the right hand side because there is only 1 there. So we need 2. So we balance oxygen by adding a water molecule. So there are now 2. So, but we've introduced 2 new hydrogen atoms, which will require us to add 2 hydrogen atoms on the left as well. So we've balanced. We need to go now to the second half reaction. So ion 2 to ion 3. So ion 2 to ion what? To ion 3. So do we need to balance any atoms there, or they're already balanced? So they're already balanced. So it's just a matter of now balancing the charges. So we're moving from 2 to 3. So that is an oxidation reaction, meaning that there is an electron being lost. Okay. How about the first half reaction? So let me move this one a bit down. The first half reaction, we have got positive 2 there. There is a zero charge there, there is no charge there, and there is no charge there. So it's 2 to 0, which is a reduction. So what can we add to 2 to give us a 0? So it's 2 electrons. So 2 electrons were what? Were gained. So, but we said we need to balance each time. We need to balance. So in the second half reaction, we are saying only an electron was lost. So we need to multiply by 2 to balance the electrons. So we can cancel out. So then the rest what remains is now what is going to help us come up with an overall what? Balanced chemical equation. Okay, so we have from the first half reaction we have that plus that. So I'll write that down. Plus in the second half reaction, ion 2. Then what do we have on the product side? So we have 2 water molecules from the first half reaction, so they can be added to give us 2 water molecules. Then from the second half reaction we have ion 3. 2 ion 3. So that is a balanced chemical equation in acidic media, shown by the presence of what? Hydrogen ions. Okay, let's try to move on to the next question now, to what is going to focus on a basic solution. Okay, so whenever you're dealing with basic solution, the procedure is the same, but what is important is you need to do after balancing in acidic media, you need to add the hydroxide ions, which we are going to do in this example. So what do we have? So we have manganese O2 plus that minus, giving us manganese O4 2 minus plus Bi3 plus. So let's try to identify the half reactions that we have. So manganese is rated to that. I'll write it. Okay, so I'll write it. So it's manganese O2 to manganese O4 2 minus. So we need to balance the atoms other than oxygen and hydrogen. Do we have manganese on both sides balanced already? Okay, so we need to balance oxygen. How many do we have on the left? There are 2. On the right, there are 4. So we need to introduce 2 water molecules here, which are going to introduce 2 oxygen atoms. So we've balanced the oxygen atoms. So how do we balance now the hydrogen atoms that we've introduced? There are 4, so we'll add 4 hydrogens on the left. Okay. From here, I can even come up with a charge. So what's the charge there? Here the charge is 0. Here the charge is also 0. There it's 2 minus. So it's 0 charge on the reactant side. Products, we have -2. Then we have 4 positives, so plus 4. So the overall charge on the products is what? 4 minus 2, which is 2. So whenever it is an increase from a lower number to a bigger number, what say is it's an oxidation reaction, meaning the difference that you have is the number of electrons were gained, that were lost. So 2 electrons were lost in that reaction. It's an oxidation reaction. We need to go on to the second half reaction, which is involving this and that. So let's try to write them now. That giving us Bi3 plus. Okay, so is that balanced? Remember, we're supposed to balance all the other atoms before we look at oxygen and hydrogen. Okay. So are they balanced? They are. Oxygen is the one that is missing. So reducing atoms. on the right hand side. So how do we do that? We add water. How many are we going to add? 3, because there are 3 oxygen atoms. So we need to balance the hydrogen. How many are they? There are 6. Okay. Is that all? So we've balanced all the atoms, including oxygen and hydrogen. So let's try to look at the charge now. So on the reactant side, we have a positive 6, minus 1. Then on the product side, we have plus 3. So water doesn't have a charge. So we are moving from 6 minus 1 is a 5. So I'm moving from positive 5 to 3. What's the difference there? The difference 2. So it's a reduction. So we are reducing by 2, meaning the electrons were gained. So it tells us it's a reduction of reaction. So in this kind of a reaction, the number of electrons are already balanced, so no need of us multiplying by any coefficient. It's just a matter of going direct to it. But let's try to cancel out what's common on both sides. So these can go, the electrons can cancel out. So anything else common? So the hydrogens, we have 6, so we need to subtract. We subtract there 4, here 4, we remain with 2 here. Okay. Anything else common? Water in the first half reaction, how many do we have? We have 2, 3. So how many are going to remain in the second? We remain with a single water molecule. Okay, so then what we've cancelled out.